Hello, AME students. Welcome to our videos that will focus on the main question in section 2.3, and that will be how to create an LU factorization of any matrix that you might have. And then in part 2, the second video of this series, we'll then talk about how we can use that LU factorization to solve a system of equations or to solve the matrix equation given a solution vector. But the first step that we have to do is actually do the factorization. Now, the idea here with LU factorization is that we're going to create two triangular matrices that when we multiply them back together, we would get to the original matrix A. Now, LU stands for lower and upper. So the two matrices that we're going to create out of this will both be triangular, which means that they are going to have zeros above or below the main diagonal. In the case of the lower triangular matrix, that's going to have zeros above the main diagonal. For the upper, that means that we're going to have zeros below the main diagonal. And there's going to be some restrictions on the size of these two matrices. Okay? Now, this process can be done for any size matrix. It doesn't necessarily have to be a square, even though in this case we are going to be trying this out on a square matrix. And that means that we can do them on tall and skinny matrices. We can do them on short and fat matrices. What is going to change, depending on what type of matrix we're doing this with, is going to be the dimensions of L and U. Now, L, every time we'll do it, is always square. And it's always going to be square depending on the height U will always have the same dimensions as A. Okay, so when we do this, we are going to see that L, in this case, will be 4 by 4, and U will also be 4 by 4 because this is a square. All right, let's get into our process here. Now, again, remember that L is going to be a square 4 by 4 matrix. It's also lower triangular. In the case of this process, it's going to be lower triangular, where there's going to be ones on all of the main diagonal values. Okay, that's going to automatically happen. U, we will undergo a process that effectively moves A into its row echelon form, not its row reduced echelon form, but its row echelon form, and that's what we're going to get from U. So we'll start off with our A, and we're going to do some processes to reduce that down into its final form. So right off the bat, we can start by writing over our original matrix, and then we'll talk about the algorithm that we're going to use to get L created and then to get A into its U form. So the first thing we're going to do is we're going to go ahead with the first column of A. And the idea here is that we're going to take that entire first column and divide it through by this top value, by effectively the pivot of that first column. And we'll do a division through, and everything else will then be entered into this first column of L, depending on how we scale down that first column. So in this case, we have 3, -3, 6, and 9. Everything gets divided through by 3 so that we can scale the pivot down to the one that we need, and everything else gets scaled. Now, from this point, we're going to effectively use the top row here to clear out the rest of column 1. All right, so doing our row echelon reduction here, the top row does not change at all, but then we're going to zero out, which means that we're going to add row 1 and row 2 together to get our first or our second row here. So we'll get -2, -1, 2. We'll subtract 2 of row 1 from row 3, which will get us 10 here. Let's see, we'll subtract -2 times 2, so that will be adding 4. And then we will subtract another 4 from -5 to give us 9. And then finally, we'll add 3 times the top row to the last row to zero out that -9. And we will get, let's see, -16. Let's see, add negative, we'll get -11. And if we add 6 to 12, we'll get 18 here. And now we're going to move on to the second column. Now notice here, over in L, we already have a 0 in the top value. We have a pivot in the second value, which means that we are only going to focus here on these 3 values. And that's what I'm going to do to reduce down and get my second column of L. I'm going to divide everything through by -2. I'll get -5 and an 8. Okay, we're effectively creating with L a set of instructions that's going to be able to undo what we're doing here to reduce U or A into its final U value. Now, once again, we will go in and we will clear out everything that remains here in second column. So we already had that 0, -2, -1, 2. That's going to stay the same. 0 here. We're going to add 5 times row 2 to row 3. Zero that out. So this will become -1 here and 1 once we add that. And then we will zero out by subtracting 8 of row 2 from row 4. That should get us a -3 here and 10 right there. And that's going to be our second step. So made a little mistake there. It's not going to be a 10, but is in fact going to be a 2 down here because we subtract 16, not 10, from the last column. Okay, and then we finish up by focusing here on this value for column 3, which means when I divide through by -1, I'll get +3 there. The last column of L is just going to be 0, 0, 1. And now we can finish up, get our entirety of U. Our final U will be 3, -7, -2, 2, 0, -2, -1, 2,